Heinemann Higher, Chapter 4, Trigonometry, Graphs and Equations, mixed exercise at the end, exercise 4 dry. Number 7, a previous higher question gives you this information and you have to find algebraically the coordinates of P and Q. Well, this is a graph I should have said that only goes up as far as pi. So it's all in radians, to boot. Well, it just looks like a X there, doesn't it? It even looks worse. Right, well, what have you got? Points of intersection means there must be things crossing there. Get the equations of the two things that cross and solve them simultaneously. So you've got y equals 0.5 being that horizontal line, and you've got y equals, it tells you anyway, although you could have inferred it from that, y equals sine of 2x minus pi upon 6. Now maybe it would have been a little bit tricky for you to have inferred that whole thing, call that 2. And then for the points of intersection, oh well, I'll state that. Intersection, so that means I'm going to substitute the equations. I think I'd rather have that on the other side, so I'll say substitute 2 and 1. So I'm going to write that out, I'm going to put this bit first, which means I've got sine 2x minus pi upon 6 equals 0.5. Now, you could change that all into degrees, work through it in degrees, and then change your answers back to radians at the end, and that would be fine. But I think just for the practice of it, because you'll only get these questions, well, most of the time, or nearly all the time, when they're just nice numbers, ones that you know, like the 30s and 45s and 60s. As you go there, there's a 30. So I'm going to do this all in radians, just for the practice of it. So the first step is going to be, get rid of the sign. So I've got inverse sine of 0.5, which you recognise as a half. Now a half would come from this triangle, 1, 2, root 3. The half, if it's the sine, would be opposite this angle. That would be the 30 degrees. And of course the 30 degrees is the pi upon 6. So that the possible answers would be, from the cast diagram, sine, tan, cos, either, since the sine's positive, you're in the first quadrant, or you're in the second quadrant. So thinking in degrees, you say either you've got 30 or you're 30 short of 180, but I'm not, I'm going to do it all in radians. So I've got 2x minus pi upon 6 is going to be, well, that's pi upon 6, or I've got pi upon 6 short of halfway round, which is pi, and since I'm talking about sixths, halfway round is 6 upon 6. So if I'm one short, I've got 5 pi upon 6. Next part's going to be, take this across and add it to both of these possible answers. Pi upon 6 plus pi upon 6 is 2 pi upon 6. Yes, I know I could cancel that down to pi upon 3, but I'm not going to. Or, adding on to that gives me 6 pi upon 6. Yes, I know that becomes pi, but I'm just going to leave it that way. But, those are just two possible answers. The thing about these sine and cosine curves is they just go on and on and on forever. Once you've got two answers, you can generate the next two, should you require them, just by adding on a wavelength. In the case of radians, just by adding on 2 pi. And you can generate the next two just by adding on another lot of 2 pi. So the general solution to this equation, inverse sine of 0.5, is going to be these two, or as many more of them as you like, achieved by adding on any number of 2 pi. I should really have said that back up there. But it makes no difference. I don't take pi upon 6 off of this, because when I shift wavelengths, the widths are still the same. Now normally you can just ignore them, but the thing is, if I'm going to be dividing, it may well turn out that they'll be quite small, and I could have gone to the next wavelength and brought some of them in, and they'd have fallen into it. So dividing by 2, now you can see that just becomes pi upon 6. That becomes 3 pi upon 6, which is pi upon 2. And in fact, since the answers have only to go up to pi upon 2, I don't need any more of the answers. Since the answers are only going to go up to pi, I don't need any more of the answers, because strictly speaking, the next would be, if I'm dividing by 2, that means I can add on, dividing everything by 2, n lots of pi. But pi added onto them will quite clearly take it beyond pi, and those two come before it. So I don't actually need these in this case, so that's not needed. So there's my two answers, which means that p must be the first of them, q must be the second. So p must be the point, pi 0.6 along and 0.5 up. and Q must be the point pi upon 2 along and 0.5 up. There, that was question 7.